All right, so we're going to spend about 50 minutes together, and you guys have already seen a lot of the storytelling that I did earlier today. I don't want to bore you with all that again, but I have some new details to give you. But more importantly, I want to walk you through a bunch of demonstrations, and I'll just have to tell you right up front. Since there were so many people presenting about Quarkus already at this conference, I want to make sure I had something different, not the same. So I have some new things in here, hopefully you've not ever seen before. But it also means I'm taking great risk. I have no idea if any of this stuff's actually going to work for me right now. But we're going to show you some really killer demonstrations. I hope you think they're pretty interesting. They give you a feel for how this technology works. And then you guys can certainly throw questions at me if we have time towards the end. If not, I'll be available afterwards. All right, so we're going to talk about Quarkus. So where does this particle accelerator thing come from that I put in the title, because I had to come up with a clever title? Is if you look at the word Quarkus, it has the word quark in it. Quark being the subatomic particle. Hopefully you've heard of that before. And so that's where the concept came from, the quark. And then us. Us is the best part of software development. Or some people might say, the worst part of software development. All us software developers. But that's the us part of it that we have here. The Supersonic Subatomic Java was actually a tagline I came up with after watching Bohemian Rhapsody. You guys know the song? Right? I'm going to make a supersonic man out of you. I'm going to make a supersonic woman out of you. So that's kind of where that came from. And a little rhyme and a little alliteration, of course, helps people remember things. So we thought it was a clever tagline, and we've been using it. But let me show you a little demonstration that I've been hacking on. It's not as far along as I wanted it to be, because I was actually going to let you guys try it with your own phone. But we're not going to be able to do that today, because I still have some work to do on it. But let me show it to you. It is this right here. You guys might have seen this little game from me before. Let me kind of show you how it works. Okay, so basically you have, it's like a Fruit Ninja style game, and the point is you kind of pop these balloons, like, let me hit one here, boom, right, hit the balloons, and if I open this up here in the background, you can kind of see what I have running here. Okay, so this is actually very complicated. I basically have the game engine itself running in this top window, and that's what these endpoints are interacting with. So if I come over here and pop a balloon, right, you can kind of see there's message traffic flowing on the background there. All the pops, all the transactions are flowing through a Kafka topic called the pop topic, pop a balloon, pop stream. That's basically pushing through the pop topic. And then I have another endpoint, another component, which is basically evaluating the stream and deciding if you get bonus points for that or not. That was the goal of this demo. So if you can kind of watch here, I'll pop a few more, right? You can kind of see, and then you can kind of see how you can go rather fast. Now, let me look at the code just briefly for the pop stream analyzing tool. So this actually uses something called reactive messaging, which we'll talk more about in a second, and I'll walk through it a little bit more slowly in a second. But reactive messaging basically has this concept of incoming, and you're going to see outgoing. Okay, so incoming is the inbound stream, and outgoing is the outbound stream, and then you decide what processing logic you want to put in the middle of that, what filtering logic, what transformation logic, what processing logic. And in this case, I'm simply ripping apart the inbound JSON object that comes from this JavaScript client. This is a browser-based client in this case. And it's basically going to rip that apart, and it's going to look for things. Is the consecutive click rate greater than 3, but less than 10? If so, you get the 3 in a row bonus. Is it the, did you click on a red balloon? Then you get the red balloon bonus. That's all it really is. It's very simple logic, but I'm basically just managing that stream of data and producing a new stream of data. You can see the bonus stream send here with the bonuses. And the cool part about it is both streams, of course, are bound to this JavaScript client. So it's got a WebSocket backend, and then it's going to basically have the inbound stream of the pops and the outbound stream of the bonuses. Let's see if we can actually make it work the way I want it to. So you can see it's evaluating these things one at a time. So let me come back over here. And so I'm just punching buttons here. All right. Now to get 3 in a row, you got to get 3 in a row before anything disappears off the screen. Well, let's see if we can get the red bonus here. Boom. All right. You'll notice that we basically had a bonus topic message sent. And if you watch closely, and this is one of the bugs I got to work on, it flashed up on screen, you got the red bonus. Okay? So it actually happened very fast there. Now let's try it for the 3 in a row. All right. Dun, 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 dun. There we go. We had 3 in a row. So you can see the 3 in a row logging out over here. And then I think I have a 10 in a row or something like that. Let's try that too. So, I got to really nail it before anything falls off. There we go. And I got the 10 in a row bonus. And you probably saw that popped up there. So this concept, the reason I'm using this as an example, it has nothing to do with the fact that I like to play with balloons or pop things like Fruit Ninja. It has most to do with the fact that I love these concepts of real-time applications. Like I can pause this application in real time as an example. I can go back and start playing it again if I want to with the audience. And I can basically say, okay, now, and the game is over, right? And you can kind of see there's my 3 achievements that I made, the red bonus, the 3-in-a-row bonus, and 10-in-a-row bonus. And so this is an application that I think is the future of next-generation web applications in general. The concept that we can have immediate interactions with our user base, either through WebSocket or SSE, server-sent events. And so I want to walk you through the concepts of WebSockets, server-sent events, and more importantly, what does it mean to have an event-driven architecture on the back end of that, leveraging something like Quarkus, which means I can make all these microservices that are hanging off this event bus known as Kafka incredibly small and fast. Okay? So we're gonna walk you through some of the piece parts of this. We don't really have time to go through this whole game, but it's complicated logic. And let me go ahead and say that I did not invent the user interface for that. A fellow named Kyle Buchanan did, and he gave me the UI. All I've been doing is building the back end for it. So let me do that, take that down. All right. So let's jump back over here and do a little slideware. But is this of interest to you guys? Is this why you're here today? You're probably thinking, no, I don't know what you're talking about. That's okay. It'll get more interesting, I promise. So I'm actually going to jump partway into the slide presentation because we covered a lot of that in the keynote already. I remember I talked about this history of Java being born long before the Linux container, long before the concept of the cloud, long before that we had this thing called Docker and thing called Kubernetes. And because of that, it runs rather poorly in some cases. Now, here's the thing to really understand about it. You know, if you're back here with this world where you have $500,000 spent on an application server, and database server and database engine, and of course, BA WebLogic and Semantic Cafe. This was fine. This was awesome. This is how most of the big enterprise applications run today. It consumes all that hardware because we dedicated the hardware per application. That's how we used to live. Many of you probably have applications that will look just like that today. You have dedicated hardware with dedicated applications on it. But in the world of the cloud, we now are making this more ephemeral. We're making it so that we can change things on the fly. And probably the most important aspect of this now is in this old world, we kept applications running for months at a time dedicated to that hardware. In other words, we wanted uptime that was multi-months. We measured in months, not days, not weeks, but months at a time. In this new world where we're practicing CI/CD and we're dynamically scaling based on data load or maybe clicks on a button like you saw me doing earlier, when the stream is coming at you that fast, you have to dynamically expand and scale out. Well, how do you achieve that? It's a fundamentally different game in this cloud world and this high-volume world we're now dealing with. So I want you guys thinking about that. That's the context that you should have, okay? And then, as I mentioned, when I did this application back in 2015 with the team that we did this for at Red Hat Summit, we had to do this with Node.js, which we tried to do it with Java, but you could not launch 1,000 Java VMs in 2.5 minutes, unless you had 1,000 dedicated servers, and we didn't have that. We had a handful of servers, and we were basically running all these Linux containers, these tiny little Linux containers running on those dedicated servers. So with Node, no problem. With Java, big problem. I want to show you where we've come to today in this presentation because you're going to see a massive difference. Now, Java is smaller and faster than Node. Okay? So I'm not going to launch 1,000 containers today, but I'll show you some of that. Also, if you go out here into Reddit and look at this posting by, what does it take to run Spring Boot on Amazon Lambda? And I think this is very profound because basically people are saying, okay, it's not really Spring Boot's fault. You can't run Java in the cloud. You can't run Java with Amazon Lambda. It's just too big and slow. It's not made for this world where things dynamically scale up based on an event, based on a stream, based on a need, and scale back down. Java was never built for that. Java was built when you had $500,000 hardware, and you could basically keep the machine running all the time. In this new world, the machine is small, costs you 20 cents an hour, and may only be living, for 5 seconds or 5 minutes. It's a very, very different world. So that's really why we worked on this thing called Quarkus. You guys have hopefully seen some presentations on this today. If not, I'm not going to spend too much time on the intro stuff because I really want to show you some more interesting stuff overall. For one thing, I'll show you the imperative and reactive programming model just to give you a little feel for that. I do have a serverless example. You've probably seen the live reload capability already, but I'll show you just a quick example of that as well. And then, of course, you can find that I'm working towards this concept of event-driven microservices backend. So you can do RESTful microservices, which is the most popular by far, but what can we do if we take HTTP out of the mix and put Kafka in the middle instead, as an example? So in other words, we have a fully event-driven architecture, and of course, it's all Kubernetes-based. This is a slide I think is important for people to understand why things have changed so dramatically just in the last 19 years or so. So Jails was added to FreeBSD in 2000. And you can kind of see what's happening right here, right? We have Solaris zones in 2005. We have the generic process container concept. We have C groups, back in 2007, kernel and user namespaces in 2008. So this is when the concept of the Linux container was born. And so Java, of course, was born long before that. And of course, we have this thing called Docker, and we have this thing called Kubernetes, and the rest is history at this point in time. Serverless has also been percolating for quite some time. Serverless architecture actually was first brought to the market back in 2011 with Iron.io and Firebase. And of course, the term serverless was coined back in 2012. So it's a 7-year-old term already. It's a 7-year-old idea already. So we've been thinking about these things for quite some time. As I mentioned, you can see that, and what you'll see when we do the demonstrations, Quarkus-based native compiled applications are vastly smaller and faster. But even if you can't go native, and what native we mean GraalVM in this case, you can still run OpenJDK JVM all day, every day with regular hotspot, and it's still smaller and faster. So even if you can't be the ultra tiny and small and fast, you can still be smaller and faster overall. So we're going to run some of this, kind of make these points. We'll get through this rapidly. So hopefully you'll see you've heard about GraalVM today. You're going to hear more about it. Oleg, I think, does his presentation on Wednesday. But in the case of GraalVM, right, you have this concept of being able to compile a Java-based application using this feature called native image, part of the substrate, that'll let you basically build a native executable binary for either Mac or Linux. Windows is coming, but either Mac or Linux, okay? Now, here's the thing I want to tell you about Kubernetes very quickly, because I'm going to show you a bunch of Kubernetes examples, is the concept of Kubernetes is actually very straightforward once you get your head around it. It has the concept of a master, which includes this thing called etcd, which is its data store, right? Its database of how it maintains its understanding of the world. You have to have 3 of these masters for a real production Kubernetes, because etcd needs 3, right? You have this concept of a scheduler, you have an API you interact with, and you have this concept of controllers. And this becomes important when we do our deeper dive into Kubernetes tomorrow afternoon. But I want to give you a feel for this because we are going to use this concept of the master. And if you're an old school Java EE person, you might be thinking, is that like a domain controller? You can kind of think of it like that if you're old school Java EE, right? Like a domain controller you might have found in WebLogic or JBoss or something like that. But the idea is that this master is responsible for interacting with this thing called a kubelet on these nodes, these worker nodes. And this is important to understand, and I'm just going to show you this right here. Like I have in this cluster that I'm going to work with today, I have, let's see here, I have all these machines running in this environment. Okay, let me bring this up. And it's a little bit small here, but we can make it a little bit bigger. So I have these different machines. Right now I have 4 nodes in my cluster. So I have 3 masters and 4 worker nodes. Those are all different computers, if you will, virtual machines in this case, and running on Amazon specifically. But those different machines are being managed by this master. But all it's doing is basically saying, run my application component on each of these nodes. And the reason this becomes important is you actually now realize, and you're paying for, anything that's slow and anything that's large. In other words, if you are a software developer and you work in a large organization, you may even have a quota that you've been assigned, where they basically said you get 2 gigs of RAM and 1 core. And you have to work within that quota for your application. So you'd start noticing when things take a lot of memory, and you start noticing things when take a lot of boot up time, okay? But the nice thing about Kubernetes is when you say, I want 2 new things, in this case, I want this particular image from Quay.io customer service 1.1.0, I want 2 replicas of that with these labels. It knows to declare, when you declare that, it puts it in etcd, but you then have it come to life. So if you kind of notice right here, these my 2 little tomcats have come to life somewhere out there on those worker nodes. Okay, and it's constantly communicating with each other. If one of these processes dies, it'll basically make sure it comes back to life someplace else. So that's the kind of cool thing about it. Now, if you're familiar with Docker, you could do this with SSH, Docker run, SSH, Docker run, SSH, Docker run, Docker run, Docker run, Docker run. Or Kubernetes does all that for you. Either way, it's fine, depending on what level of labor that you want. So Kubernetes is constantly watching your environment, and through the kubelet running on each of those worker nodes, it's doing the Docker run on your behalf. Okay? Now, here's the thing that's cool about this thing called Quarkus. I can actually, in that same space of 2 things, I can put 20 in its place, and the same memory footprint, potentially, and the same CPU footprint. So that's how you should be thinking about this new world of, new way of thinking, right? How much density can I have? And so I'm going to quickly show you these things and get out of this mode of kind of slideware. But let's do that. I mentioned Cogito already, so you guys hopefully saw the presentation on that. There's the link to it. I want to actually show you the Kafka aspects of small RAI and reactive messaging and other things. So I want to mostly be in demo mode as we go through this today. So this is the Quarkus website. The way you would actually start a brand new application, hopefully you guys saw this already, but you come in here to quarkus.io there. That's the website. Say get started. And then you can say read the guide. And you can come in here and basically just highlight this right out of the, you can take this whole line of code, but I'm going to take just this one, Maven plugin. I can come over here and let's go to this guy over here and list this window here. And then I'm going to say Krakow. And then you can come in here and change into that directory and then run this command. And it's going to basically prompt you for everything else it needs. So this plugin right here is nothing I've installed. There's no POM XML or anything like that at this point in time, but there will be. So if I say Burr Sutter and Krakow, and then I want this to be the Krakow project, and then I want it to be 1.0 snapshot, yep, give me all that. That's fantastic. Tree, let's see, we got a bunch of stuff in there now. It generated a basic project for me. I can bring up Visual Studio Code. Dun, 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 come on, Visual Studio Code, there we go. I can come in here and look at this project. So this is the standard getting started process. I'm just wanting to show you this only because we're going to go well beyond getting started, but I want to give you a feel for that. And you can kind of then say, real simple, I want to open up a terminal window, or you could go back to the previous terminal, MVN, and compile, and Quarkus, helps if you spell correctly, dev. All right, and that puts it in development mode. And the reason this is important is if you're familiar with Node.js, this is the Node.js development model. In other words, I can now come in here and bring up my browser, and let's go over here to localhost 8080, and I have this hello endpoint that was added. Okay, there it is, right there, hello, no big deal. And if I come in here and modify it, and I make this aloha, helps if I spell aloha correctly, hit save. So all you do is edit, save, refresh, okay? And there we go. And it dynamically reloads what it needs to ensure that you have the most recent representation. It does require, though, the save in order to get the refresh to work. Okay, so don't forget to save. But this concept means you can now build in a rapid cycle. Okay, so this is how I built that balloon popping game completely, both the client side, which has it's a node front end, if you will, with AngularJS, and then the back end was using the same technique. I'm basically trying things, edit, save, refresh, edit, save, refresh. And that's kind of the model you would go through. Now, if I want to add something more complex than this, I can easily come in here now and say, Maven, Quarkus, list extensions, and you can see the extensions that are available to you. You can see there's a bunch of them here. And these are things that are known to work in this highly optimized, incredibly small, incredibly fast world of Quarkus, meaning they also compile down to native. So you can kind of see there's a lot of capability here, like Hibernate and Flyaway and Camel and JDBC. Of course, we have Postgres, we have MySQL there. We have things like the reactive messaging piece, which is what I'll show you in a bit. We're going to talk to you about Kafka as well. But things that were just added are things like Cogito, you saw earlier. AMQP was just added as well. And this is, again, a project just born in March, evolving very rapidly. So I can easily come here and add a few extensions. I'll just copy this line here. And then let's say I want the REST easy with JSONB, which gives me a nice REST capability. I might want the Postgres as an example. And we're going to move beyond this in a second. I just want to give you a feel for the basics, though. And what else do I want here? I want, let's see, I got the Postgres. Oh, I want Hibernate Panache, right? You saw this in Marcus's presentation, hopefully earlier. So this is a nice Hibernate programming model, Hibernate but made easy. All right, so I can come back now and say, oh, yep, my POM XML was updated. You can kind of see this right here. There's the POM XML updates. You'll see there's REST easy JSONB, JDBC PostgreSQL. I can come up here and go back into development mode, and now I can do some interesting things. I now have the ability to build a full database application. But in order to do that, I do need to populate this properties file, which I have a copy of this stuff right here. I'm just going to cheat and put it in, just real fast, and I can call this Krakow. Dun, dun, dun. And so this is the model, again, to get started, right? Very straightforward. Whoop, you don't need two my's there. Dun, 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 dun. Just make it easy. Hit save. And then I need to go in here and modify my database structure, or actually build a database so I can have it. So I can basically say create a new login group, and definition, all right, and privileges, and yes, all right, if I did that correctly, and then build another database. for this and map it to that user I just created. There we go. Save. All right. And now I can come in here and do something kind of fun. Whoop. Kind of fun. There we go. Kind of fun. I can say something like this. I can say new customer.java. And I can say, not that. Class. I can mark this as an entity class, right? So if you're familiar with Hibernate or JPA, I can start doing things like that. But the difference is I can say extends panache entity. There we go. Shift Option O, get that right one in there. And I can say something like public string. I'm just giving you an example of this just so you get a feel for it. Public string last name. Int, but int age, that would be good. And public Boolean active. This is an active customer, yes or no. But I don't have to do the getters and setters for that. And it helps if you get the semicolons right. Okay. And where's my browser again? Refresh. Let's see if all worked out. Go over here. Go to our database. Not that one. This one. And so what happens, if I did this correctly, we should have the schema generation already done. And there's customer. Okay? Now, the schema generation, of course, is traditional Hibernate capability. But I can now go on and just build the whole rest of the database application, right? Using the model you just saw. Edit, save, refresh. Edit, save, refresh. Add something for post handling, something for get handling, a delete, et cetera, et cetera. And normally that's what I would do in a presentation like this one. But you've already seen that already today. Hopefully. And so I want to keep moving here because I think that's super interesting, that's not exactly what I want to show you. We want to go a little bit further beyond that. So again, build the app that way. I've already built one of these applications already. Okay, so I already have it built, fully fleshed out. So I'm going to close that. Let's go ahead and close that there as well. We'll come back to that stuff. Okay, and let me go switch to this little window here. So let me see if this will work for me. Target. I've already done the compile down to native, I think, on this one. Yeah, so target to do. Here's an example of that application where it's been completed, the whole application. Compile it down to native. You can see in this case, it started in 0.068 seconds. So that is the full CRUD-based application, including the database connectivity, including the connection pool, setting up the schema, and all of that, right inside, everything that you saw earlier, but now it's the whole application. And so it has a user interface on front. I can put in 2. And let me see, this actually connects to this database. Let's see if we got that right. And table, refresh. And to-do table. And let's see here. I like going back to the user interface to see if, in fact, I did things right. So there's 1 and 2. And, if I want to add 3. So let's put something in completely different. Love Java. And hit refresh here. All right, love Java. So it's a full working application. The reason, though, that I'm interested in that concept of where it starts here, again, let's hit Control-C and start it again. Okay, you can see in this case it started in 0.057 seconds. Now, you might not care in a long-running application that runs for months at a time where we have a nice waterfall model where we basically get all our people together and we have this big high-ceremony deployment. But in a situation where you have to deploy rapidly or deploying daily or maybe hourly or maybe every few minutes, this sort of thing does matter. So to give you a feel for that, I'm going to come here and actually show you this application now is running on Kubernetes. So I did the kubectl get pods here. I have 2 of it running right now. Let me see. I have a poller. I'm going to basically poll the endpoint. Let me shut that down. And actually, I want to show you what this endpoint looks like. And then all this is basically it has this path called pod host. It's going to return the host name. It's going to return the computer name this Java application thinks it's running on. Okay? And right now I have it mapped to v3. This is currently v1, which is actually running in production. That's v1 is running behind this machine and this machine. And if you look closely, you can see it's giving me 50-50 load balancing between those 2 machines. So the cool thing about it from a Java standpoint, it thinks it's running on 2 completely different computers. It doesn't realize these are Linux containers running inside Kubernetes in a very tightly constrained environment. But I can have some fun with this. Let me actually come up here now and say, go back over here. And I'm just having fun. As I said, I've not really run this presentation this way before. I'm kind of having a little fun with you guys, being a little experimental. But I'm going to come over here now and come over here and say, this is the deployment. This is right here. Let's just crank it up. Yeah, that's fine. Go. All right? So basically, we just said, Kubernetes, I need 9 of these things to run. I need 9 servers running right now. Get them up as fast as you possibly can. And you can see it's in this container creating phase, where that basically means it's told etcd, I want this new world view to be available to me. I want it deployed. Find servers to run it on. And now they're all up and running. So we went from 2 computers to 9 computers in a few seconds there. And you can kind of see it's automatically load balancing across all of them. And it is a working application. So, if I come over here now and look at it, I can come over here and say, love Java also. It's still the same working application. If I want to, I have another little poller that basically pulls out the data from it. So you can kind of see where it says love Java there. And I can say, cool stuff. And you can kind of see it's cool stuff. So it is a total working application. Now, here's what's more powerful. Again, for those of you who are looking at DevOps, CI/CD, continuous integration, continuous delivery, continuous deployment, and you're trying to think this through, what does it mean to actually make a change to the application? So I actually have some scripts here. I want to kind of show you, let's do this. Let's roll it out to V2. Let's roll version 2 of this application out to production. You'll see what happens here is it goes through its rolling update. Basically, of the 9, it starts updating them pretty rapidly, and you can kind of see that process. And again, it's doing this across that cluster of servers that I have already created. You can see there's some terminating, there's some container creating. You notice there's already one version 2 in the mix. Let me make sure my poller keeps working here. But you can see it actually going through those servers, moving them from V1, V2. And my curl sometimes gets hung up. We'll get it going there. Come on, curl. And depends on the network performance. We're definitely relying on the network here. Come on, now all version 2. It's working on it. But that concept is incredibly powerful, and you want to do that as fast as possible. So again, that's a whole application, CRUD-based application talking to a database, the Postgres database in this case, and you can kind of see it's doing its rolling update now. And I will have to work on that curl command to get it to behave better. Okay, and the same would be if I want to roll it back now. That's the coolest thing. This is a blue-green deployment. If I want to roll back, I can to version 1 in a few seconds. That's kind of the idea. Okay, so let me come back and downscale this application so it's not using all the resources here. I've got other things I want to do. I'll just take it back down to 3. How about that? And again, with Kubernetes, you basically declare what your needs are and it goes away. Now I want to show you one other little application that's kind of related here. Okay. Dun, dun, dun. Kubernetes side by side. I'm going to switch namespaces here to a different one, and we're going to do a watch kubectl get pods. I want to show you another example of scaling because I think this is actually more powerful. So right now I have no pods running. Let me bring up the UI. Deployments. But I do have deployments. Let's look at them real quick. I have side by side. This is actually a technology known as Knative. I'll do a deeper dive on Knative tomorrow. But you can kind of see there's my Spring Boot app, a Node.js app, a Quarkus-based app. They all do the same thing, but there's 0 pods running right now because there's 0 load associated with the application. So at Knative in a Kubernetes architecture, it basically will see that you have no requirements for these pods, these running, living, breathing things, and it downscales it to 0 by default. You can basically say, I want 1 or 2 to be my minimum, but it basically looks for things that aren't have no load and downscales it. That's kind of the point of Knative. So in other words, I have no pods running because I have no need. But now if I come over here and let me do this one. So if I burst out now and hit it with a ton of load, in this case, it's going to do 40 concurrent users, and you can see what it's trying to do. It's trying to bring up 4 of these pods right now. 4 computers, if you will, 4 Quarkus-based applications, trying to bring those up. It's going to do that as fast as possible, and you can kind of see it's not quite there yet. You got to have 3 of 3 in the running category, and you notice there's 3 containers inside these pods. That's because there's a sidecar for Istio and a sidecar for Knative, and whoop, the first one is up, and you can kind of see it right there. Okay, that took about 28 seconds. I'm going to also just keep a poller on it so it'll stay alive. And let me also bring up the Node.js application now too. So it took about, how long did it take? 28 seconds to bring all those up. Let's try this one. Again, the time will vary based on a lot of different factors. So I'm not basically saying let's look at the side-by-side time here. I have no idea if it'll be faster and slower. But I'm more interested in seeing this concept, dynamic scale out. Again, using a technology like Knative, where a serverless architecture, this sort of lightweightness and fast startup time really does matter. So here goes our Node.js applications. They're coming online right now. And so there we go. So that took about 22 seconds there. Let me do my little polar, and that way, again, I keep it up. And the reason this interests me, let's go check out my Prometheus over here and look at these guys running. So let's see right here. That is, let's see here. Come on, whoop. We got to get the right data. Okay, so this is my Node application running right there. And, okay, and let's see what, if you'll notice also, it's starting to downscale based on load. Okay, so you'll notice one thing that's kind of important to understand. It's already down to one Quarkus application because I started that one earlier, and there's not enough load right now to keep it up. It's also downscaling the Node.js applications too, dynamically right now. You see I'm basically turning that off. And then I can monitor the memory of these guys, and you can kind of see, let's see here, that's a Node application. That is a Node application. There's my Quarkus application. I don't know what's down here. Again, because some of these processes are now being terminated, we're going to get different data sets. But you can kind of see that basically the Node.js application and the Quarkus application are competing very well with each other. Now, this is kind of mind-blowing if you think about it. I'm running a Java-based application in 18 megs of RAM, it looks like on that one. Okay? So the thing we like showing people is you can run it at 20 megs of RAM, you can run it at 40 megs of RAM, you can run it at 50 megs of RAM, and that is kind of mind-blowing from a Java standpoint. But it really matters in this world where you're dealing in a highly ephemeral, highly dynamic world where things might change all the time, and you have to basically scale rapidly. So another way to say it is you don't have to pre-scale for peak. You can basically dynamically scale for peak and then downscale when peak is over. So for most of our applications, probably at Monday morning at 9 o'clock local time is when you get all your users showing up, when everyone shows up for work Monday morning. But Sunday afternoon, there's not much activity at all. Sunday morning at 2 a.m., there's no activity. Why have all those servers where you're paying for the cloud provider to have them up and running when you can basically use those CPUs and memory for other things if you want? So that's kind of a cool way to look at it. And let's see here, we're down to just one node and one Quarkus, and if we basically stop this load here, you'll see those downscale after about 90 seconds also. But this is my Node app. There's my Quarkus app. So in this case, I saved 6 megs of RAM in this particular case. And actually, the API-based application you saw me use earlier, it's about 30 megs of RAM, just slightly bigger than the Node.js Hello World. Okay, how are we doing on time? I forgot exactly when I'm supposed to finish. So I think it's at 4:40, right? Well, right, we'll keep going here. And then I want to show you a couple other things, because this gets a lot more interesting. And actually, I want to show this part of the slide deck. By the way, this is all bit.ly Quarkus Java for you guys if you want to access the slide deck. And so what I'm going to talk about next is this concept of reactive messaging, and then show you what it means and show you the programming model for it. So one of the things we're really focused on at Quarkus is not only making it fast and small and leveraging this technology called GraalVM and making sure frameworks like Hibernate and InfiniSpan and Camel can compile down to native in this new world. What you saw earlier with Mario with Drools and JBPM, et cetera. That's all cool, but what can we do to be incredibly innovative to give you next generation programming models for this next generation of code, especially in an event-driven architecture? So Small Rye, you probably have not heard of before, but it's a micro-profile reference implementation, and it kind of has this new capability called reactive messaging. So where does reactive messaging come from? Well, you probably have heard of reactive programming, and you've seen presentations on it, and you may have even heard of reactive streams, and you may have even heard of reactive extensions like RxJava or Reactor. Okay, this is actually coming into the micro-profile world, something called reactive messaging. Another standard, another open source world, right? An open source implementation as well as an open standard that we're working on. And that gives you a different kind of programming model. And you can even see here the link. We could go there and check it out if we want to. I added the link, though, for you guys to come review this. But I want to show you the code more live, and we'll have some fun with that. But right here, it has real simple annotations. I have an incoming stream and an outgoing stream. Very straightforward. I got to say incoming, outgoing, and then you do what you will with that body, okay? And then you can kind of see there's an application properties file, like you saw me use earlier with the setting up the database. In this case, you set up your incoming stream and your outgoing stream, right? So incoming, outgoing. And I called this stream input, that one output, just to make it very straightforward and simple. But let's see if we can have a little fun with that. I want to show you this example now. And over here, okay? So let me bring up my Kafka. All right, I have it here as Docker Compose, basically get it launched. This Kafka uses a technology called stremz, which is and just to kind of mention it, it is a operator that works in the context of, all right, in context of, not that one, Oh, yeah, down here, right there. There we go. Basically, it's an operator for Kafka to run on top of Kubernetes. So in other words, it's a management bit of infrastructure to keep your Kubernetes up and running and happy on a Kubernetes infrastructure. Basically, you're supposed to keep 3 brokers and 3 zookeepers. That's what it does, right? And make sure that stuff's all good. So let's see if we can kind of show you this thing now. Okay? I realize I'm moving rather fast, but hopefully we'll have a little fun. Let's see here. I want to bring up my producer. This is the producer that will send the message. And actually, let's do this. Let's bring up the code. Yeah, let's bring up the code real quick so you guys can check it out. All right. Nope. Go away. Let's try this. So here's the producer of those messages. I'm not sure if everybody uses Kafka, but the nice thing is you can basically say add inject, add stream, my stream. And again, that's defined in the properties, my stream, outgoing, my stream. And I want it to go to this topic in Kafka that Kafka is currently running on localhost in this case. Has these 2 serializers, both for the key and the value. And it's basically a simple setup. I set up those properties, and now I basically say add inject my stream. And in this case, this code's job is to send new messages, emit new messages based on the get, and it's going to produce a JSON body that looks like this, and it's going to see send, right? Very straightforward when it comes to the sender. So let's go ahead and bring that up right here. And I'm basically just bringing up, again, in dev mode, so I can live code against this one if I wanted to, make changes to it. But let me also bring up my consumer. All right, compile, Quarkus, dev. And let's bring up my consumer, one of my consumers. This is just a WebSocket consumer. There we go. You can see it connecting to the Kafka right there. Let's go here. And I think it's this one, this window. Get connected. There we go. And now if I come over here, this is the producer for that. Okay, and basically as soon as I do the get on it, you can see it produces a new message, and then it basically pushes it out through this WebSocket right here. And so that's an important thing to understand. You can bridge the world of browsers to this world of Kafka very easily. So in this case, it's a WebSocket. Let me bring up this one also. Compile, Quarkus dev. Okay. Oh, wait. I want to bring up the code so we can see the code, so let's do that. And then bring up the engine itself. Okay, so let's look at this code in particular. This is where it gets interesting. Here's an example where it's just a simple application scoped, my stream subscriber. Okay, here I have the input and the output like you saw in the slide earlier. If you look here, they're defined here. So here's my incoming input, my outgoing output. These are arbitrary names. If I wanted to call this thing Burr, I could have. But I didn't. I called it output just to make it easier for my brain. And so you can say input and output, and it's going to go from the input of A topic to the output of B topic. That's kind of the idea. It's basically just bridging the world. But let me come over here now and bring up this guy. And, all right, and this one has an SSE. So that has an outbound stream. So you can kind of see there's already 2 messages in the stream. But let me go ahead and bring these up now, all right? So if I come over here and hit refresh, okay? So you can kind of see that it's basically just punching through the messages I create over here to those other 2 guys. So this one's listening on the A topic, this one's listening on the B topic, and it's just going through. But let's kind of make this a little bit more interesting, all right? That is where I have just a simple, let's say, where it says log here. Let me double check that. Input 4, right? There's the log, so that's the right bit of code there. Let me just comment this out. So instead of live coding, we're going to do live commenting. How about that? All right. I want to come in here now and show you a little bit one that's a little more complicated, and that is this one. Okay. Let's show you this one. So this is an example where I don't necessarily want all the outbound messages. Why do I have an error there? Process input. So I must have another process here someplace. Dun, 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 dun. Duplicate method. Yeah. So where is the other process? Oh, that's because I have this one down here. Okay. And so, this is a good example. Let's see here. Yes. All I do is comment out these annotations. So let's do that. Okay, so I have my incoming and my outgoing. That's going from A to B, if you remember earlier. In this case, though, it's going to apply a filter. The logic basically, and this is it's a reactive style programming model, stream style programming model with the lambda there. But in this case, it's going to look at the body of that message, and it's going to decide if it ends with 8, then it's going to allow it through. Very simple filter because it has a very simple data structure. But, I was just having fun with that. And so, let me make sure that I hit save. Let me hit save, and you have to refresh. I have a little reset flag there. So I basically just refreshed it. And then if I come over here now and okay, so you can kind of, unfortunately, that says customer 14 there, 16, and down here, we're looking for 8s, 18. You notice there's 18 came through, okay? And if I keep going, 20 doesn't come through, 22, okay, no, it's 24, 26, 28, there's 28. All right? So basically now it's filtering just for that piece of string, right? You could kind of make it do anything you want to do there, but that's kind of a neat way of thinking about it. But I can still live code against this particular piece of this application logic. So let's say I want to do a mapping. The mapping allows me to do a transform, right? So the transform logic is very, very simple. It's simply going to just basically rip apart that JSON, and it's going to put special K in it. That's all it's going to do. And so if I hit save here, again, I use my refresh. And if I come back over here now and hit refresh, okay, there's special K, dun, 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 and only the ones that begin with or end with 8 have that special K treatment. So this concept of being able to just really work directly off a stream is one thing I want you guys to think about. The concept of I want to just change my logic, still interacting with these Kafka topics as they are, and then I can basically live change the code. And I see that as incredibly productive, incredibly powerful. You can kind of see I have even other examples here where I go further with it and try to basically, really modify the inbound and outbound JSON. Okay? In other words, what if I really want the JSON to be fundamentally different on the outbound side than before? So if you remember that balloon popping game I showed you earlier, that's exactly what it's doing. It wants to look at every pop, every transaction, every pop. But at that point, once it's decided it's a bonus or not, that's when the new stream is outputted. A new stream is emitted. So that concept is very powerful, right? So incoming and outgoing, and I just have bunches of examples that we won't have time to go through today. Okay? So just keep that one in mind. I want you guys thinking about that. And then let me make sure we cover a couple other tidbits here. All right. Dun, 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 not that. This slide deck. And Kafka streams. So let me kind of show you that also. Again, all of this is documented on the website. So you go here, you go to guides, you kind of check this out. So I want to look at Kafka right here. And so Apache Kafka, AMQP reactive messaging. Kafka is also reactive messaging, but Kafka streams. And then you can use the Kafka streams programming model. So right here, did I have the right link? Yeah. Yep, fantastic. And so if you were using the Kafka Streams programming model before, now you can also compile this down to a native executable and interact with the Streams API, if you're familiar with it, of Kafka Streams. So here's a good example of that right here. So in this case, it's using weather information from weather stations in real-time analysis and aggregating that data across multiple weather stations. Okay? So this concept is very powerful. And I do fundamentally believe that in the new world that we're going to be living in going forward, where like the balloon popping game is a simple example of a high transaction volume, where you no longer have living in a world of simple get, put, post, and delete. Because the volume we're seeing now from our mobile applications or APIs, our IoT devices is so high, it looks like a stream. And you have to think in terms of stream-based processing, and of course, dynamically scaling out basically consumers, producers, transformers, and filters against that new API. One other thing I'll show you though, because I have one other little demo here, is let me show you this right here, and let's see if I can make it work. This is a tricky one, but I just want to show you because I spent a lot of time on this particular one to try to get it working. Okay, get namespaces. And Kubernetes. Let's see. This is my Franz for Kafka. Let's see here. So watch kubectl get pods. So in this case, I have a full Kafka broker running inside that cluster I showed you earlier, where I was scaling things up and down. But what I have now is this concept of a Kafka source. I don't know, we'll talk about this more when I talk about the Knative capabilities, but the idea is very straightforward. I have producers and consumers, and in this case, it's a Kafka source that's tied to my business logic. So that means my business logic doesn't even have to have the concept of, you can see in this case, it's just a generic post. So this is a microservice written in a way that you would write a traditional microservice. The only difference is the input on this side is JSON. It's known as a cloud event, and this is where my Kafka component can now feed data in. So this is another way to build a dynamically scalable application, and let's see if we can make that work. So kubectl get routes. Let me see. I have a route for this guy right here. And let's bring up a little browser window here. And, dun, 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 dun. Okay, let me send in a message. It's just a simple endpoint. And so that producer running right there, and you'll notice what happens. This guy right here is just coming to life now. So again, that dynamic scale-out capability based on not just HTTP traffic, but a Kafka traffic. And so you're going to see more and more of these kinds of capabilities where it's not just Kafka traffic or HTTP traffic, it might be FTP traffic, it might be AWS SQS, it might be Google Pub Sub. All that's an example of Knative eventing. And in this case, we're now processing messages via this new mechanism. And you'll basically see it downscale. So this is kind of the culmination of all the different things I've been showing you. And yeah, let's do my logging of that. And so let's just get the user container, make it a little bit easier. And let's see here. There we go. So there's that message. And if I come over here and hit it a little bit harder, okay, or add more messages to it. There we go. Oh, come on, browser. Is there a network die on us? Come on. Oh. Da, da, da. So I tend to put way too many complicated things in my presentations. So let's see. We got through most of it. There we go. So apparently the network is going very slow, but there we're now getting messages through the system. Okay? So, and as long as there's Kafka messages, that component stays up. When that component is no longer needed because there's no Kafka messages, it downscales it to 0. So my whole point with this is we want you thinking about this new world of Java where you're living where things have to dynamically scale up, things have to dynamically scale down, things have to use a little bit of memory instead of a lot of memory. And again, you can compile this down to native, and these are all native executables based on GraalVM. There's a deeper dive presentation on this later this week. Definitely check that out. But that gives you the ability to kind of now do some really interesting things. The primary difference with what you'll see with regular old GraalVM versus what we've done with Quarkus is all related to these frameworks and APIs that we brought forward. So if you look here, you'll see things like Vertex, Hibernate, Kubernetes capability, things like Kafka clients I just showed you here. Things like that have made it into this native executable world, and that's what we've been working on. So we also welcome you to come contribute extensions like these as well. If there's a library that you love, we have a whole guide on showing you how to migrate it to this new native world, which could be very powerful, very, very advanced for what you might need to do. And then also, one thing I would just kind of mention about Hibernate as a good example, the way we got started on this effort was with Hibernate. You guys might not know that Red Hat is the provider of Hibernate, one of the most popular open source projects in the ecosystem. And Sane, our project lead on that, started investigating this, I think about 1.5 years ago. And what he found was there's all these aspects of Hibernate that cause things to be slower and larger at runtime. For instance, we load up an XML file just because we load up an XML file in case you had one. Okay, remember the old way of doing Hibernate was with XML, not with annotations. But if you do everything with annotations, why pay the performance penalty, both memory and startup time, with an XML file? The same thing with all that dynamic class path scanning and looking for annotations. Again, that can be optimized. And so if you look at it like this, what GraalVM is doing is dead code and elimination. That's how it gets down to that native executable that's so small and fast. And so a simple way to think of that is, in the case of Hibernate, what if you're connecting to not Oracle? Okay? In other words, I'm connecting to Postgres like you saw me here. Well, there's still 400 references to Oracle in the Hibernate code base that you're carrying along with you. But you don't need that. You don't need the Oracle object relational mapping if you're only talking to Postgres. And therefore, when you compile it down to native, all that gets eliminated as part of the process of GraalVM removing it. And then now you have that much smaller, faster thing. So I am basically out of time, but I do have maybe a moment for a question or two. But do go to the website and do check out the slide deck available here at bit.ly Quarkus Java. Okay? Do we have any questions? A stunned silence. I do have stickers I provided at the bottom of the stage, so when we finish here, you can actually run up and grab some. And then if you have other questions for me, I will be doing the deep dive on Istio, Knative, and all that Kubernetes stuff tomorrow afternoon, and just in that one category.